Hello, welcome to Apsana classes. Today in this video, let's look about fixed bias and drawbacks of it. So we have a transistor here and where its emitter is connected to ground, and we have an RB resistor that is connected between the base and plus VCC voltage, and we have the uh, collector resistor. So let's apply KVL at input side. Then we get plus VCC is equal to, so the current that is here flowing is IB and IC. So IB RB plus, and the here voltage that is having here is VBE. It is a base, so VBE. So VBE. And now the required value of DC base current IB for the given operating point is obtained by the selecting proper RB value. So we have here IB is equal to IC by beta, right? Where if you look at here, base current is directly proportional to IC, isn't it? Okay, then let come to this point. Find RB. To find RB, VCC minus VBE is equal to IBRB, where RB is equal to VCC minus VBE by IB. So here VBE is very less than VCE. So we can neglect VBE. So we can neglect VBE. Then we get RB is equal to VCC by IB. We know that the DC load line is taken at the output characteristics of a CE configuration V, CE and IC, and the point that we get on x-axis and y-axis are VCC and VCC by RC. Here, as IC is proportional to IB, so we can take VCC by RC as it is VCC by RB we get. So the value of RB can be calculated from the equation. The base emitter voltage VB is very small, so that we have neglected. Therefore, the resistor RB is approximately RB is equal to VCC by IB, or IB is equal to VCC by RB. Here VCC is a fixed known quantity and RB is chosen at some suitable value. Thus, the current IB is constant. So here VCC is constant. See here IB is equal to VCC by RB, as VCC is constant and RB should be taken at a suitable fixed, so that RB can be fixed, which thus IC will be constant. So this is about fixed bias. Let's look about its stability factor. Stability factor. We know that generally stability factor is S is equal to 1 plus beta by 1 minus beta DIB by DIC, as IB is independent of IC. So IB is independent of IC, then it is constant. So the derivative for the constant is 0. So that whole term will be 0. So S is equal to 1 plus beta by 1 minus beta of 0. So that S is equal to 1 plus beta. So 1 minus beta. So 0. So 1 plus beta by 1, which is equal to 1 plus beta. So here the stability factor is high. As stability factor is high, stability will be low. As stability factor is high, then stability will be low, so that the operating point cannot be constant and it's shift up or down where the input can be evolved with some distorted output. So this is the drawback, and we have some more drawback that it does not provide stability, and as IB is independent of IC, so that very poor stability is secured. So as stability is poor, then there may be chance of thermal runaway. If thermal runaway is occurred, then the transistor may be burn out. So there are maybe chances that the transistor may be burn out. So this is about fixed bias and circuit and its stability factor. Thank you for watching. Please like, share and subscribe.